Okay, so let's look at problem number 31. An alpha particle. An alpha particle is a helium nucleus, so it's two protons and two neutrons, and the mass of this thing is alpha particle is that 6.64 times 10 minus 27 kgs. Its charge is that of two protons, so 3.2 times 10 minus 19 coulombs. It travels in a circular path of radius 25 centimeters in a uniform magnetic field of magnitude 1.5 Tesla. So what is this? What is the speed of the particle? What is its kinetic energy in electron volts? Through what potential difference must the charge be accelerated in order to give this kinetic energy? Okay, so let's do a diagram first. Alright, so what we'll do is we'll make the magnetic field come out of the plane of the paper. So there's the magnetic field. Okay, there's the circular path for the alpha particle. It's a positively charged particle, and let's figure out what direction should it travel into to go in a circle like this. So we need a centripetal force in this direction, which would be the magnetic force provided by the magnetic force. So let's say if the particle moved in this direction, if you turn this to V to B, the force would be in that direction. Okay, so that's the direction in which the alpha particle is moving. So it's going in a circle clockwise. Okay, all right, so r is the radius of the circle. All right, so part A, what is the speed of the particle? Okay, mv square by r. The centripetal force is provided by, well, let me write it like so. The centripetal force is provided by the magnetic force. The magnetic force is Q V cross B, and V and B are perpendicular to each other, so the magnitude of the magnetic force is QVB. Okay, so mv square by r, the centripetal force is QVB. And what we're trying to find is the speed of the particle, so one of the v's cancels, so v is equal to QB r over m. Alright, so let's put in the values. Q is 3.2 into 10 to the minus 19 coulombs. The magnetic field is 1.5 Tesla. The radius is 25 centimeters. 25 into 10 minus 2 meters. And the mass is 6.64 into 10 minus 27 kgs. Alright, so as always, let's take care of the powers of 10 first. This is 10 minus 21. When this comes to the top, that becomes 10 to the plus 27. 27 minus 21 is 10 to the 6. Okay, so that's 10 to the 6. This is velocity, so it'll be meters per second. And the other factors are 3.2 into 1.5 into 25 divided by 6.64. All right, so okay, so this works out too. Okay, let's add a page. Okay, so the velocity works out to 1.8 into 10 to the power 7 meters per second. Okay, That's the velocity. That's the velocity of the alpha particle. What is its kinetic energy in electron volts? Okay, so the kinetic energy is 1/2 mv square, and so it's 1/2. The mass of the particle is 6.64 times 10 to the minus 27 kgs. 1.8 times 10 to the 7 meters per second square. Alright, again, let's take care of powers of 10. That's 10 to the 14 times, that's minus 27. Minus 27 plus 14 is minus 13. So 1/2 6.64 times 1.8 squared times 10 minus 13 joules. This is energy. Okay, so let's look at this. 0.5 times 6.6. Okay, so 1.07, 1.08 into 10 minus 12 joules. Okay, and you can look up conversions. 1 electron volt is 1.6 times 10 to the minus 19 joules. Okay, that's the conversion. Oh, actually, so I'll do it in the next line. And so this is equal to 1.08 10 to the minus 12 joules times that, and that is equal to 1.08 divided by 1.6, and that's 6.75 into this 19 comes to the top, that becomes 10 to the plus 7, 10, so this is 10 to the power 6 electron volts. Okay, so this is a convenient unit. You'll see in a second why. Okay, so that's part B. Now what does this say? Through what potential difference must the particle be accelerated in order to give it this kinetic energy? Okay, so part C, let's add a page below. Okay, part C. Now, all right, so the kinetic energy gained is equal to the potential energy lost. Okay, and so it gains that energy, and the potential energy is the charge times the electric potential through which it needs to be accelerated. The particle needs to be accelerated. Now the charge of the alpha particle is 2e delta v, and that's equal to delta ke. Okay, or the increase in potential energy. So the potential through which you need to accelerate this alpha particle is its kinetic energy divided by 2e. Oh, well, actually, so, okay. So this Okay, so let me be a little more specific here. So let a little more clear here. This is potential, electric potential. So what this means is, if this is 100 volt, uh, and the charge of the particle was E, its energy would be 100 electron volt. Okay, so um, so here's what we'll do. Okay, so the change in kinetic energy is, so here's how we'll do it: 6.75 into 10 to the power 6 electron volt 2e. So the e cancels, and 6.75 divided by 2 is 3.38 million volts. Okay, so that's the potential through which you need to accelerate the alpha particle for it to gain that energy, 3.3 million volts. Okay, so that does that problem. That takes care of that problem.